All right. Hi, everyone. I'm Chris Gearhart. I'm the Student Services Lead at Udacity for the AI Nanodegree program. Today, I'm going to be doing a walkthrough on the first of our Term 1 projects, the Sudoku project. The goal for this Q&A is to help kind of break down some of the barriers folks run into when they get started first thing in the Nanodegree program and help kind of kickstart your way through this project in particular. The way we're going to structure this Q&A is that I'm going to go through a walkthrough of the project, probably for the majority of the time that we have available. And then at the end, I'm going to wrap up with some questions based on some that we collected earlier and some that we'll take live sort of at the end. So with that out of the way, let's get started. I'm kind of going to go through, let me see. The way I want to do this is I'm going to switch over to screen share and we'll kind of go through the classroom and have a look at the project. Okay, so here in the classroom, you should have already been able to kind of jump through the welcome section and setting up with Anaconda, and then you dive right in with Sudoku. We don't do a whole lot of lecturing. We kind of jump right in to have a look at some of the key ideas in AI by solving a particular problem. And in this case, we're using Sudoku. The first introduction introduces the project, and then we get started right away with a description of the problem, along with some of the goals. At the end of this lesson, and hopefully at the end of the project, you should have some intuition for some of the key ideas and using them, like constraint propagation and search that are introduced here. The lectures will go into these in more detail later, but the idea is that we're just introducing some of the information that's used in AI. Constraint propagation is logically using problem constraints to reduce the number of legal values for a variable in a problem that's constructed this way. And search in this instance is kind of defined for an agent as systematically considering the outcomes of various sequences of actions that it might take. Now, both of those are kind of straight out of the artificial intelligence modern approach textbook that a lot of this class is structured after. And those are kind of really key concepts underlying this project. So the idea is, to solve a project, we have to come up with a good way of encoding the problem. And for Sudoku, we're going to represent the board a couple of different ways. In order to go through this project and understand everything that we've got laid out, we have to introduce some of the naming conventions that we're going to use to refer to things. The project lays out here that rows are going to be labeled by letters, columns are going to be labeled by numbers, and that gives us a familiar grid that we can use, coordinates like A1 to reference a box here. We could use, C7 to reference a box here, and so forth. We don't have a specific name for these 3x3 sections of the grid that form a unit, but they are drawn differently to help identify them, at least here in the classroom. The other names we need are boxes, units, and peers. Boxes, as I've referred to them, are just the individual tiles in the grid. Units are any group of, a complete row, a complete column, or one of the 3x3 segments. Those are all referred to as units. And then the last is peers. Peers are, for a row, for instance, peers are any pair of boxes that are in that same row, or any pair that are in the same column, or any pair that are in the same 3 by 3. All of those would be considered pairs. The important thing here is that we're going to use a couple of different representations to encode the board. It's presented here as, given with a string, and then we're also going to use a dictionary to encode the representation of the board. And the idea there is that the string is kind of a convenient way to put in puzzles or to encode them and input them to the program. But it doesn't do a great job of representing the problem. One of the probably most important concepts in AI is choosing a representation of a problem that's appropriate for how you're trying to solve it. And in this case, it's a little more natural to represent the problem for constraint satisfaction and for search using the more natural indices of the box locations and representing the values that each of those boxes could take on in the value key value of the dictionary. You're not really expected to know that this would be a better representation without any prior experience or exposure in artificial intelligence. We're kind of giving it to you as this will help. But as you go through the course, you'll start to see how important it is to come up with an appropriate representation for any particular problem, and different techniques that you might use, like constraint propagation and some of the different search techniques, either require or lend themselves to some representations better than others. So the other thing here is that this function was introduced, this cross function, and I wanted to come back and highlight it because for folks that are new to Python, there's a couple of interesting things going on here that it's worth calling attention to, at least so that you have some insight into the names of things in Python, so that you can look for more information if you're interested or if you're having trouble with it. So this is essentially constructing a list in place out of a list comprehension. So it's similar to other loop constructs in both Python and other languages. The idea is that if A and B, that are the inputs to the function, are some kind of iterable collection type, that could be a string, that could be a list, it could be a tuple, any of those kinds of things, then this will just pull one item from A each time that it can and call it S, and it'll pull one item from B, call it T. So this is effectively two nested for loops. And there are some peculiarities of the order that these will actually be enumerated in. You can go and kind of look up list comprehensions for Python and get a better idea of what's going on there. Since strings are treated as iterable collections in Python, this creates a list of new strings. So that's how we get down here, this exact list. And actually, you can kind of implicitly see the enumeration order of the two lists since we're crossing the rows and the columns here. From there, let's see, you're going to define each of the units, the row, column, and square units. These are just collections of pairs, and they're going to be used when we apply the different strategies that are introduced as part of the project. The first strategy that's introduced is elimination. This is probably the most obvious strategy for Sudoku. The fundamental idea is if one cell has a value assigned to it, then none of its peers can have that value assigned. This is actually one of the rules of Sudoku, and so that's another common concept in AI is that the rules of a particular domain are directly encoded as part of sort of the solution to it. So that covers the elimination strategy. The only choice strategy is that, excuse me, if there's only one box in a unit that allows a particular digit, then that box must be assigned that digit. And then, so both of these are kind of developed here in the classroom. And then constraint propagation is introduced briefly as the technique that's going to be used to apply each of those techniques to Sudoku puzzles. The other strategies are search. This is used to actually propagate the constraints. You know, as we define search for an AI agent, it's trying every possible action, and then you kind of back up if you run out of choices. And then we move on to coding the solution. Now, this is the part where we're going to move out of. Let me make sure that I have screen shared properly. We're going to move out of the classroom and come over to GitHub, where we have the project available. You can pull this down using Git, and I'll demonstrate that real quick. I'm not going to demonstrate setting up all of the Android or Anaconda environment. I'm not going to demonstrate downloading the whole Anaconda environment, but I will demonstrate setting this part up. So I'm just going to make a folder real quick called temp, and then we'll come here and grab the URL to clone the repository and clone it there. So now when we go into that folder in our terminal, you'll see that it's pulled down a copy of you know, all of the files that are included, including the hidden folder for the project assistant and everything else that you need to go through the project. The README contains information that you have to fill in a couple of answers when you submit the project. It has some basic instructions for installing in Anaconda and Python 3, the step-by-step things that you need to complete as part of the project. The solution.py file contains all of the code that you have to modify as part of this project. And several of the functions can be copied directly out of the classroom once you've passed the associated quizzes. So from there, now that we've got a copy on our local machine, I'm going to close that one because I've already got a copy here. And you can, I just switched to a text editor. This is just a copy of Sublime Text that I installed. And I loaded the folder that contains the project on the side here. So the only thing I've done is open up the solution.py file, which is the only one that contains any code that you have to modify as part of this project. Several of the functions are already filled in. You just have to modify them. And several of the other ones you can pull out of the classroom. So the main steps are, at least for the functions that come out of the classroom, are going to be to switch back to the classroom, find things like encoding the board, and work through you can move this function out into the solution file here, and then for functions like grid values, you're going to end up creating something. This can be done very quickly in a very similar way to what you've done or what you do here with the cross function. In particular, in the newer versions of Python, you can construct dictionaries with the same kind of literal syntax. So returning just any key value pair So we should be able to do something like this. And this isn't the answer to this function, but it demonstrates sort of the syntax for producing a dictionary literal, similar to the way we did with a list comprehension. So here we can see that it produces a dictionary that has a key for each one, A, B, C, and D, and it has a value for each one. This makes sense because it's a double nested for, and so what it did is it assigned 1 to each key, then 2 to each key, then 3 to each key, and 4 to each key. So it's going to end up with all of them being labeled 4. From there, you will move on to the display function. This is, I don't think this is one of the graded functions. I think this is actually available in the classroom, but you're welcome to modify it to be more detailed. The eliminate function, this one is available in the classroom. Only choice, reduce puzzle, and I think search are all done in the classroom. For some of the functions, like only choice and eliminate, you're given values, and you have to, let me see if I can pull up the doc strings that are in the classroom. I'm going to turn off screen share for a moment because my screen might have the answers. So let me try and make sure that those are not there. And then I'll turn screen sharing back on and we can go through it. Okay. Got one more. All right. All right, coming back to the screen share. So back to the classroom. If we look at the implementation requirements for the eliminate function, then what we'll see is it's going to take as an input a puzzle in dictionary form. So that's going to be one of the outputs from our function that converts it to, here we go, from our grid values function. So you'll take a puzzle as an input like this one here, and then you're going to run it through the grid values function to generate a dictionary representation, and then you will pass that into one of your strategy functions like eliminate or only choice. The solver is going to be the function that kind of pulls all of these pieces together. We'll kind of pull that up in the classroom in just a second and go through that as well. So the function is supposed to iterate over all of the boxes in the puzzle that have only one value assigned to them and remove that value from every one of its peers. So in the encoding the board section, we talked about generating those lists of all of the units, the 3x3 boxes, the rows, and the columns. And the only thing that you're going to do in the eliminate function is iterate over every box that's in the puzzle grid, from A1, A2, A3, all the way through I9, and you're going to look for any of them that have only one value assigned, and then remove that value from every peer of that box through any of the other units. From a how do we perspective, actually implementing that, you can iterate through dictionaries in one of a couple of different ways in Python. So since values is a dictionary that has keys and values, what we can do is, and that's just a comment, I'm just writing down the thought. But what you can do is, if you just iterate directly over it, it by default gives each of the keys. Those are in no particular order. Dictionaries are not like an array. It's not going to give you A1, A2, A3. It's going to come out in somewhat of a random order. It's not actually random. They just don't, there's no guarantee of the order that things are going to come out in. This is basically the same as iterating over the keys that are in the dictionary. Instead of iterating over the keys, you can also iterate over the values. And if you want to instead get both the key and the value for each element in the dictionary, you can iterate over items. And so from here, we would be able to, you can do anything that you want with K or with V. I believe that our representation of the unit list, you would be able to filter through that unit list to look for matching keys in order to identify the peers of each one of the boxes as you do this iteration. The second strategy, if we kind of roll down to that one, you're going to take, again, an input puzzle as a dictionary, and you're going to go through all of the units and look for those that have only one possible box. Or look for a unit where only one of the cells has a particular option. In this case, it's the digit 1. So it's going to be a similar thing, although instead of iterating over the dictionary itself, for only choice, you're going to end up iterating over some other set of units. I don't think we've defined that. So you can copy out some of the helper code that's found in the encoding the board section for things like all units is going to be some list that contains some items. And then from there, you should be able to reference it inside of things like the only choice function. But what you'll do is you'll say for unit in all units, and then you'll apply the strategy for only choice. You're going to look for any peer within that box that's the only one to have a particular value. In both cases, and really including the naked twins function or strategy as well, you could technically, I think, call it recursively or repeatedly until it stops replacing the values. I believe that the project assistant will accept either convention, either calling it once or calling it repeatedly until there's no change. But I think the intent originally in the assignment was only to call each strategy once within solve. It could be more efficient to call them more than once, but that's not really a question or part of the project itself. So in addition to all of the parts of the project here, the project also has some tests that you can run. And these are run, I think it's laid out in the README file. Maybe not, but I'll add it. I think they're unit tests. Yes. So we should just be able to say, oh, I'm not in the project folder. I'm going to fail everything because I didn't implement any of the solution. You can actually get a little bit more information out of this. Unit test only shows a little dot if you pass the tests. It doesn't do a great job of showing of providing a lot of information. If you add the -v, it gives you a little bit more information. You'll at least see confirmation that every test was run. So I think that covers that part of it. And the last part is that once you've completed everything, and actually I'm going to redo this part as well. I just created a new terminal window, and all I'm going to do here is move back to our Udacity directory. This is the one that we cloned the repository into, or I did it earlier. And we're going to activate our Anaconda environment for the AIND program. So that's where, over here, that's where I got this little prefix on my prompt. So the earlier lecture unit covering installing and configuring Anaconda is going to go through all the steps that are required to install Anaconda and install all the packages that are required for the AIND program. There's a file, a YAML file that's got everything you need, and it'll set that environment up pretty quickly. So on top of that, now we're back here. When we want to submit the project, it should just be Udacity submit. And you're going to put in your username and password, and it'll try submitting. My authentication failed because these are obviously made up credentials, but when you submit the project, it'll run another set of tests similar to the solution tests here and provide a bunch of feedback along with a zip file. I think it didn't make my zip file because my authentication failed, it looks like. But it'll put a zip file in your folder on your local machine. That's what you actually end up coming back to the classroom and submitting down here. So I think that I've burned through the project walkthrough a little bit faster than expected, which means I am going to turn off the screen share and we can kind of jump into the Q&A session a little bit earlier. We did have one question that came in beforehand, and it was asking for a demonstration of how to code things in Anaconda on your local machine. I think the answer is you code them in a text editor. You can use any of a number of various IDEs that are out there. PyCharm is popular. Sublime Text, TextPad, or Notepad++. I mean, there's a bunch of them out there. Any one of those will work. You just have to be able to modify the plain text file on your local machine. And then Anaconda is just the package manager and data science, scientific computing environment that we're using to run the projects. So it's just the Python distribution, but it's not a distribution that you're going to actually run the Python scripts with. So if there are additional questions about how to set up Anaconda or how to edit source code or those kinds of things on your local environment, let's kind of follow up on Slack, maybe the office hours channel or on the forum. All right, I'm going to start rolling through the questions that are on YouTube, and we'll go from there. Let's see. I see something about project not showing as completed in the classroom. I would send an email to ai-support@udacity.com and ask about that. I used Google account to sign in to Udacity. Which password should I use for Udacity submit? The answer there is that the project assistant has instructions for, if you look at the README file on the Sudoku project, give me a second and I'll screen share. Okay, so if you come to the README file or just the project page on GitHub and you scroll down towards the bottom in the README, you'll see that in the submission section, there's a link to finding authentication tokens for other authentication methods. So here it's going to show you all these steps. I'll actually demonstrate because it's not that hard. So I'm going to download a copy of this file. On my machine, it's going to put that in the downloads folder. So if I come back here to my terminal, I should be able to check the contents of my downloads folder. And one of the things that I've got is that JWT file. That file needs to be placed on Unix-like environments in a folder under your home directory. You have to create a new hidden folder. That's what the prefix dot means, and save it as JWT there. So if I put, if I make the directory first, then I can move that file into that folder. And then actually now if I type Udacity submit, it won't ask me for a username and password. It'll actually try and submit my code and yell at me with all of the feedback for the tests that it's failing. So it shows me some errors. This is not well formatted. I'll see if I can get somebody to look at that. But you can skip most of this information here, and you can focus just on so I have a syntax error in the code that I submitted. I didn't indent a block around line 63 of solution.py. I bet if we switch over here and we look around line 63, there's a for loop that has no body. And so that's not going to work. If we get rid of that and we get rid of other syntax errors that I introduced, then we should be able to resubmit and get different, cleaner feedback. Usually when the feedback is misformatted like that, it's because something actually interrupted the project assistant script from running. One of the things that does that is syntax errors in your code. So if it's not able to import the module, then it never loads the portion of the project assistant that nicely formats your output. So if you ever see that sort of JSON formatted stuff, look around in your code for some kind of syntax error. A lot of times it's as simple as trying to run your code locally. I would bet that if we add those lines back into the code here and try and just execute that script, what we're going to get is an error on line 63 expecting an indentation block. And it's the same error that we got from the project assistant. So the best way to troubleshoot if you run into those kind of problems is probably to try and execute the script locally. Even if you just invoke that script, you know, this wouldn't, the idea is that'll be the fastest way to let the runtime environment for Python try and identify any problems that you've got in your code. So okay. Having trouble defining variables with what you stated about dict not behaving like an array. Is there any more, can you provide some clarification on that issue? Let's see. Defining variables in Python is a little different than other languages in the sense that variables are just names that are like they're tags more than variables. You're not actually allocating memory when you name something. So here, if I said, foo equals values, that's not going to allocate any new memory. What that's going to do is assign a new name that I can use within the local scope of the function only choice to the object that is referenced by values. Now, if I imported the copy module, then you can, take like a deep copy of values And what that will end up doing is actually taking whatever's in values and making a wholly new copy of it in memory and assigning the name foo to that. In that case, this, but the only reason that that actually works is because you're constructing a new copy here and then assigning that name to the data that's been created. Yeah, I'll try and get a room next time that doesn't have ping pong background noise. So Walter Llama, did that help at all in terms of describing, defining variables? There are several ways to construct things like dictionaries in Python. I demonstrated that literal syntax before, but you can also do other kinds of constructors for dictionaries. For instance, if we wanted to do something similar to what we did before, if I just said A is equal to ABC and B is equal to 1, 2, 3, then we can say for X in A, for Y in B, and we can assign, new dict X equals Y. And I'm going to make it the same as we did before. Oh, I didn't actually print anything. And so it's going to do the same thing as before. So our terse, syntax from before, where we said new dict is literally, X, Y, for X in A, for Y in B, we can actually comment out all of these other lines, and this should be the same. So those two are equivalent. You can also initialize, rather than using an empty literal, it's the same as using the actual keyword constructor for that class. Let's see, using counter to collect twins, however, it returns location and not values of the twins. Aha. Counter is a subclass of, I was not sharing the screen that whole time. That's fantastic. So let's go back through that, and then I'll talk specifically about counter. So what I did is I created a dictionary. That's line 3 here. Just use the same data that I used earlier in the video. And then I used 2 nested for loops to add each one of those key and value pairs into that dictionary. And if we run that, we should get the same thing we got before, with each one of the keys tied to the value 4. And it's like I said before, since it's 2 nested for loops, when we run through these Y values in B, we're overwriting each of the earlier iterations. And that's why they all end up with the value 4. This is equivalent, and you can actually even get rid of the constructor here, or the declaration there, and make it the same thing that we saw before, this kind of dictionary literal here. And so when I run that, I get the exact same thing. And then finally, I was showing that the dictionary doesn't have to be defined as an empty literal. You can use the keyword dict to create an empty dictionary as well, which is, I think, the class constructor for that class. Now, the counter is from the collections module. And a counter is a dict that won't raise a key error when you enter a key that's not in the dictionary. Instead, it just increments a counter associated with that key. So when you pass in a string like 1, 2, 3, 4, I think it might be capitalized. I don't recall. If we do that here, what I'm actually going to do is extend this a little bit. And then I'm going to make and then we should be able to say see if this works. There we go. So it won't raise a key error. If you see, this is actually an empty counter at this point. If we print it, I think even items will work here. It's going to show you that it's an empty dictionary. But then when we run through this for loop for each of the values here in B, it's going to just increment the counter by 1 each time. So when we print count at the end, you're going to see that the key 1 was seen twice, the key 2 was seen twice, the key 3 was seen twice, and the key 4 was only seen once. So you can actually, I don't think you could actually do this in a comprehension rather than a for loop. You might be able to, but it's a little bit abusive because, well, maybe you can. I don't know if you'd want to, because what you'd end up with is a list full of items. I think that instead what you can just do is call the counter constructor directly on your list. So if we remove all of this and just call the counter directly on B, I think it's going to give us the same thing. And I think there's a way to add, you'd have to pull up the documentation for the collections module and look through counter to find out. Let's see. Does using list or dictionary comprehensions have any benefits other than concise code as compared to traditional ways of populating it? So very minimal. It's generally considered more Pythonic to use list comprehensions and dictionary comprehensions. It's certainly not required. You can also definitely take it overboard. It's you can make very complicated things with list and dictionary comprehensions, but the general rule of thumb is that if you can fit it on 1 line, or if there's a natural break to make it 2 lines, it's okay to make it a list comprehension rather than to roll out a whole for loop. The other thing is there are some very minimal speed benefits. Comprehensions are a tiny bit faster than writing a for loop. Python is not a compiled language, and so it has to do a lot of dynamic lookups every time that you invoke a function or every time that you loop through on a variable. And what that means is that it isn't able generally, the CPython runtime is not generally able to optimize certain things because I'm going to share my screen again here and show off some of the dynamic aspects of Python. In a lot of languages, you have to declare what items are going to go into a list. So this assignments list here could only have integers, or could only have strings, or could only have string pointers, or things like that. In Python, it's totally acceptable to do things like we can append A, which is a string. We can append B, which is a string, and then we can append 7, the number. And if we print out the assignments, then what we're going to see is it doesn't care that we're putting strings and numbers in the same list. But what that means is that the runtime has to accommodate that every time that you loop through items in a list. List comprehensions are able to do a couple of optimizations that generally can't happen in other types of loop flow control in Python. So it's almost entirely a theoretical benefit, but there's a little bit, it is sometimes more performant to use comprehension as opposed to using a normal or a more traditional loop or flow control. That gets me to the bottom of the list of questions. Any last minute questions? Well, basically you look cooler. It does actually tend to make the code more concise, and depending on the libraries that you're using, it can be a bigger deal. If you start doing things with computer vision or use OpenCV, for instance, doing any looping in Python is inherently slow because of the issues with dynamic typing and doing everything at runtime. When you have a library or a module that is written in some compiled extension like C, then you can offload a lot of things by not writing loops in Python. So from a performance perspective, it's usually a good idea to avoid writing loops in Python at all. And if you have to, using a comprehension when it's a small comprehension is typically a better idea than writing a multiple nested for loops. Any last minute questions? We've still got a couple of minutes. So if there are any other questions out there, I'd like to take advantage of the time. Okay, well, I think that's, the solve function. Let me try and pull that up real quick before I share my screen, make sure that I don't have solutions in there. I'll go through both the reduce puzzle and the solve function if I can quickly. There we go. Okay. So I'm going to switch over to constraint propagation, and we'll scroll down to the reduce puzzle function. So once you have each of those functions that we've talked about laid out, the naked twins, the eliminate, the only choice functions, then you can come over to the reduce puzzle. And the idea behind this is that from some starting state, if you call each one of those functions, you'll reduce the complexity of the puzzle through constraint propagation by eliminating some of the values that were available at the start. Your input values here, you'll eliminate some of those values from the puzzle, and you'll be left with a simpler puzzle. So the function stops if it gets solved. So you'll have to think about how you can do that. The main thing is what happens if you call all of your when a puzzle is solved, it should be easy to test that all of the values are appropriate for a solved puzzle. If it doesn't solve the Sudoku, you want to stop when it stops making progress. We talked a little bit about making copies of objects, so refer back to that part of the video to see some tips that you can do to kind of keep a copy of the state of it when you started, and so that you can look at it after you've applied all of the strategies to compare and see if you're making any progress. The search part is going to code the actual solve, and you're going to use depth first search and propagation to solve the puzzle. The idea here is very similar. You're going to, or one strategy is to kind of make a copy of the values. This is going to be a recursive search for depth first search, and at each step what you're going to do is try and apply your reduce puzzle function and continue until it either solves the puzzle or you run out of, or calling reduce puzzle makes no further progress, at which point you know that that branch is invalid, and you can recurse back up the tree. You can return some kind of failure and move back up the tree and try an alternative assignment. There is pseudocode for probably the depth first search. If you look for, if you just Google for it, AIMA is again the textbook that a lot of this is based on, and so you should be able to find in the markdown here, probably in search. I don't know if it actually has one for depth first search, but I'll double check and I'll see if I can add a link on Slack or somewhere. Okay, I think we're about out of time, and I think that covered everything in the project. Join us on Slack or in the forums if you have additional questions. The Office Hours channel is a great place to ask, along with P Sudoku is the other channel on Slack that's dedicated to this project. Hopefully I'll see you all there, and thanks for joining us. Bye.